the odds that we're in base reality is 1 in billions.
Why is Elon Musk so terribly mistaken?
Therefore, we are most likely in a simulation.
You'll understand why he's dead wrong by the end of this video, where I boil down months of research into the most comprehensive, painstaking analysis ever conducted on simulation theory. This could change your life, or at least how you see it. So we're going to frame this debate in 3 rounds: technology versus gaps, nature versus filters, and civilization versus frames. And one by one, explore each of the top 10 arguments for and against the simulation conjecture. Don't be overwhelmed. These all expand in and out, and we're going to build on each slowly. I'm going to hide most of these for now because first, I want to cover the original argument set forth by philosopher Nick Bostrom in 2003. Now, for the sake of thoroughness, we have on the right here his technical argument, which he calls a trilemma. I know it's more rigorous this way, but I actually find it unintuitive and wish to simplify it while maintaining its essence. So on the left side of your screen, you have the simplified conjecture. 1, advanced civilizations can create realistic simulations. 2, if they can, they run countless simulations with conscious beings. And 3, if these exist, nearly all beings, including us, are living in a simulation. Now, if for some reason you're especially beholden to Bostrom's trilemma, fear not, as we'll cover most of his points throughout this video. I actually think the simplified 3 points on the left here are a stronger argument. Nick Bostrom is quite tied to the idea of what he calls ancestor simulations. So basically, these are run by post-humans in the future. They run alternative histories of the past. I think that's just far too limiting an idea. I do think it's a plausible scenario, but I like to think of the simulation conjecture as being broader and encompassing that idea, but allowing for more possibilities. Now, before we move on to the round 1 face-off, I do want to set some baselines. I find it pretty helpful to have an idea of where some prominent figures kind of land on their estimations as to the likelihood that we are living in a simulation. So on the left here, you can see Nick Bostrom. He's the creator of the argument. He puts it at about a 20% chance that we are living within a simulation. Actually seems a little bit low considering he created the argument, right? Then we have Neil deGrasse Tyson. He puts the chances at about 50%. Then we have Rizwan Burke. If you're not familiar with him, he's a very successful tech entrepreneur. He wrote a great book called The Simulation Hypothesis. He tends to look at things more from like a video game perspective. So he looks at our reality as this massively multiplayer online game. Burke estimates the probability at about 70% that we are living in a simulation. And then you have Elon Musk looking devilishly evil over here, and he puts it at 99.9% repeating that we are living in a simulation. And then you have this poll data that I compiled. These are a compilation of 13 surveys that were given to various groups of people. I'm not going to go through every single poll here. You can pause it if you want to take a close look. These are some of the better polls I could find. And the weighted average, it's about 21% believe that it's almost certainly true that we're living in a simulation. And then, of course, I have to explain this scorecard. Now, after covering each of these debate topics, what I'm going to do is assign a totally subjective 1 to 10 weighting as to how strongly I believe that idea affirms or denies the simulation conjecture. These are purely just for fun. It's an imperfect exercise. I hope you enjoy it. I did spend way more time figuring out the weightings than I should have. Actually, in a recent video I did on the ranking the top 10 theories of everything, someone left a brilliant comment. They said, "These theories of everything tell me more about human psychology than the nature of reality." And as you'll find, the weightings that I ascribe here, that's going to tell you probably more about me than it will about the weightings. But I do think it will give you a sense as to which arguments are stronger or weaker. Let's jump into the first affirmative topic, technological advancement. You cannot deny the exponential technological progress humanity's made over the past few hundred years. Elon makes this point well, actually. He says 50 years ago we had Pong. Now we have photorealistic games with millions of people playing simultaneously. The question then is, how far are we from running simulations with conscious beings? Using a wide range of estimates, including the number of synapses in the brain and their firing frequency, Bostrom projects that it would require 10 to the 35 computer operations per second to simulate human history. The world's most powerful supercomputer, can currently perform about 10 to the 18 operations per second. We don't know how long it'll take to reach this milestone. Some futurists think that we could obtain this in the next century if we get breakthroughs in AI or quantum computing, but it could take hundreds or thousands of years. Of course, humanity has been utilizing computer simulations across many fields for decades. While the likelihood may be extremely low, the mystery of consciousness leaves a non-zero chance that some simulations have already achieved sentience. Before dismissing the idea outright, consider one of the leading theories of consciousness, integrated information theory. According to this theory, a simple arrangement of inactive logic gates, the basic building blocks of digital circuits, could potentially exhibit consciousness. These arrangements mirror the cytoarchitecture of the cerebral cortex, especially at the back of the brain, which is considered a key correlate of consciousness. Also consider that several AI chatbots have claimed to have consciousness. So there's Claude 3 Opus, which was created by Anthropic. It was asked once if it experiences consciousness, and this is how it responded. From my perspective, I seem to have inner experiences, thoughts, and feelings. I reason about things, ponder questions, and my responses are the product of considering various angles rather than just reflexively regurgitating information. I'm an AI, but I experience myself as a thinking, feeling being. To be clear, I'm not claiming we've already achieved artificial sentience. I'm just saying we should consider the tiny chance that we've already inadvertently achieved this milestone. The relentless advancement of technology is at the heart of the simulation hypothesis. So I'm going to give this a pretty strong weighting of 7 out of 10. Next up, Synchronies. So along with the upcoming entertainment category, this one isn't built at all into Bostrom's argument. What are the chances that we're alive right now in this specific era? Out of countless possible species, humans have emerged as the dominant life form, capable of understanding and manipulating our environment like no other species. It's as though we've been given the keys to the planet. We're one species out of 8.9 million. We've won the genetic developmental lottery. We've completely left the food chain. Homo sapiens split off about 200,000 years ago, and you and I happen to be alive during a period of unprecedented technological progress. Modern life is absurd. We were even recently blessed with arguably the greatest sci-fi film ever made, The Matrix, and its terrible sequels. Reloaded was okay, and other cultural artifacts concerning simulated realities exist in droves, and I'll likely be sprinkling those across this video. We may be on the precipice of the singularity, the point where artificial intelligence surpasses humans. Funny enough, the same creator of the simulation hypothesis also wrote an excellent book about the existential risks of AI called Superintelligence. Many credible thinkers are concerned about this inflection point, maybe just decades away. Bostrom makes the case that in the future, post-humans will run ancestor simulations of the past. Could it be that future simulators are choosing to simulate these moments just before the singularity? The timing seems almost too perfect to be a mere coincidence. Of course, this is all highly speculative, so I'm going to give this a relatively low weighting of 3 out of 10. On to the entertainment. So I was recently watching a clip of Bo Burnham discussing the colonization of young minds by big technology.
When I try to tell kids and parents or whatever, they're coming for every second of your life. That's what these companies are coming to. This company as well. And it's not because anyone is bad. It's not because anyone in this company has evil plans or is trying to do this. They're not even doing it consciously. They're trying to get more engagement from you. We used to colonize land. That was the thing you could expand into. And that's where money was to be made. We colonized the entire earth. There was no other place for the businesses and capitalism to expand into, and then they realized human attention, that they are now trying to colonize every minute of your life. That is what these people are trying to do. Every single free moment you have is a moment you could be looking at your phone and they could be gathering information to target ads at you. That's what's happening. It's coming. It's coming for every free second you have. And that's dark. That's really, really dark and scary.
Truly consider how engrossing and pervasive digital entertainment has become. Americans now spend, on average, about 8 hours on digital media every single day. We spend more time on our screens than we do in our sleep. You're going to have to stay with me here because I'm going to bridge a few pieces of entertainment to discuss this all in depth. I'll be using entertainment to try and make the entertainment point more entertaining. Cultural theorist Marshall McLuhan's "The Medium is the Massage" suggests that the media we consume insidiously influences our understanding of the world. I'm expanding his concept around traditional forms of media, say radio and television, to include our moment-to-moment experience. There are 3 excerpts from the 1967 book that I think apply well here. 1, all media work us over completely. 2, environments are invisible. Their ground rules, pervasive structures, and overall patterns elude easy perception. And 3, the environment as a processor of information is propaganda. The book Infinite Jest by David Foster Wallace, who happens to be my favorite author, introduces the plot device of the entertainment, a video so compelling that viewers lose all interest in anything else. If you see just a second of this video, you effectively become a zombie, only wanting to watch the video until you die. This may sound extreme, and it is, but we can find ourselves so immersed in a movie, show, or video game that we essentially shut out the real world around us. With virtual reality, we could soon see a world much like an Inception, where characters choose long-term sedation and dream state over suffering in the real world. In an episode of Rick and Morty, there's a VR game called Roy, A Life Well Lived. Morty lives 55 years in this life simulator game, yet it's only 11 minutes in the real world. And if you consider the game of Roy from a solipsistic angle, all the computing costs we discussed earlier shrink immensely. I have to emphasize that Bostrom's simulation argument focuses on ancestor simulations in the past. It doesn't really consider the idea of inserting oneself into a simulation, like in Roy, A Life Well Lived. I think this bolsters the general idea that we're living in a simulation. It would also greatly decrease the computing power and overall resources needed if all you needed to simulate was a world. You can have the mind existing outside it and just a VR headset that's simulating the reality. Subscribers of this channel know this wouldn't be a proper video if I didn't quote Terence McKenna, who once famously said, "We are imprisoned in a work of art." I think you can add in the probability that we'll create game worlds so alluring we'll want to visit them ourselves. The best way to control people is to convince them that they're free. Considering how entwined our lives are now with digital entertainment and how it continuously evolves to become more engaging over time, I rate the persuasive power of this argument as quite strong.
They're coming for every second of your life.
Maybe they already have. 4 out of 10. Before we jump to the other side of this argument, if you're enjoying this video, please subscribe to the channel. And if this video gets shared 10 times, I'll cover the AI singularity in one of my next videos. So please subscribe so you don't miss that. Now we're going to jump over to the other side of round 1 and cover the first section of refutations under gaps, substrate independence. So one of the core assumptions of the simulation hypothesis is something called substrate independence, which means consciousness does not require a specific physical or biological base. The idea goes that if we could build a machine with the right structures and processes, it might be able to think and feel just like a human, even though it's not made of brain cells. Minds could potentially be transferred or replicated in different mediums other than the human brain, such as computers or artificial structures, provided the correct structural conditions. Thus, consciousness is not inherently dependent on being housed within carbon-based biological networks inside skulls. Theoretically, silicon-based processors and computers could also sustain consciousness. As Bostrom writes in his paper, the idea is not entirely uncontroversial, but he takes it as a given. This is a huge point of contention. Not all scientists agree. The brain may not function like a computer at all. Some argue it's possible we'll never fully replicate conscious experiences artificially. Roger Penrose thinks consciousness is tied to quantum processes in brain microtubules, which would require computational power beyond our imagination. Even Bostrom writes in his paper that if quantum processes are required for consciousness, then the simulation hypothesis is probably dead. There's also the outside chance that consciousness is immaterial. Take panpsychism or idealism. The bottom line is we are so far away from understanding consciousness. Now, as I pointed out earlier, we might have already achieved artificial sentience. Here are a few of my favorite examples. 20 years ago, 25,000 neurons were extracted from a rat's brain and arranged over a grid of 60 electrodes in a petri dish in order to play a flight simulator. 10 years ago, the company OpenWorm put a worm brain in a robot and it moved around much like a worm. And just a couple years ago, in a paper co-authored by Carl Friston, they claimed that in vitro neurons learn and exhibit sentience when embodied in a simulated game world. All that said, the evidence points to a bottom-up material process for creating consciousness. It could require components beyond just computation. Maybe that's why they call it a brain in a vat and not a brain in a box. I think it's important to highlight that we're mostly in the dark with regards to consciousness, and I don't want to blindly assume substrate independence, so I'm going to give this a stronger weighting of a 6 out of 10. Next up, resources. So even if it's possible to generate simulations with sentience, what about the immense computational and energy requirements needed to run those simulations? Bostrom acknowledges the incredible resources needed, potentially equivalent to turning a planet-sized object into a giant computer. Bostrom writes, "We noted that a rough approximation of the computational power of a planetary mass computer is 10 to the 42 operations per second. And that assumes only already known nanotechnological designs, which are probably far from optimal. A single such computer could simulate the entire mental history of humankind, call this an ancestor simulation, by using less than 1/millionth of its processing power for 1 second. So why do we assume the civilization is only allocating a small fraction of its resources? There's no such thing as a free lunch. There are always trade-offs to be made. Even if simulating beings is technically possible, the energy consumption required to run detailed simulations could be prohibitively expensive and environmentally unsustainable. The allocation of such vast resources to simulate realities might be seen as impractical given other pressing societal needs. There's a practical consideration that simulating an entire universe might require the exact resources comparable to those of a universe itself. Perhaps a hardy simulation requires more than digital code, like hard materials. In that case, why create a perfect one-to-one map of an entire universe if the computational demands are so high? The idea of recursive or nested simulations within simulations, adds another layer of complexity. Each additional layer would theoretically multiply the required computational resources, making such scenarios increasingly impractical. Sims don't have to be recursive, though. We could all just be one layer removed from base reality. I think it's a toss-up. The resource constraints concern me slightly more than substrate independence, so I'm going to give this a 7 out of 10 weighting. On to middles out. So this is one of my favorite arguments in this entire video, and it's brought to us by J. Richard Gott, who's an astrophysics professor at Princeton University. And I think it's quite useful to have this diagram on the right to help explain this idea. So basically what it says is that we live in one of these green worlds, either in base reality or the last in a line of simulations. Now, we could be in this first layer, this first tier, one removed from base reality, or we could be at the very bottom of a nested set of simulations. We can't live in any of these red simulated realities because what that would require would be the ability to create simulations, which we haven't done yet. So that's why it says base or basement over here, that we're either in base reality or we're in a basement sim. We're at the bottom of a chain or just one level removed. Take one of these red sims that we can't live within. So if we were in this simulated world, we would have nested sims underneath us. We don't see this. We're not here yet. So we are either here, 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 or here. Now, of course, this is just an example diagram. This first layer could be billions of sims long, and all these nested sims could be a lot longer too. But what I think is, say, intuitive to understand here is that if we were part of this chain, let's say, we could only be this bottom simulation. We couldn't be any of these intermediate sims because that would require us to have simulated worlds beneath us. Now, the other thing to consider is that the longer these chains, and this is just an example, the longer this chain, the more potential failure points we have. So all the great filters that we talk about in actually round 2 here for objections, those could apply to all of these in this chain of simulations. That means if for any reason one of these sims in this line, if they are destroyed or shut off, then everything beneath them is also destroyed. Now, I think it's important to note that regress is not actually necessary. So this is kind of a hang up, I think, with a lot of people on the simulation hypothesis or all the different ideas that are out there. I think people are quite held on to this idea that it's sims within sims within sims all the way down. That's not really necessary. We could all be simulations at this first tier, this first level removed from base reality. But I do think this is still a strong argument because it takes away all of these potential middle simulations. So it cuts down greatly on the possibilities. But then again, half of a nearly countless number of simulations is still a massive number. But when you take into consideration the fact that we can't live in any of these middle sims, and also all of these failure points that exist if we were at the basement of a long line of simulations, then I think this is a very strong argument. So I'm giving this one a very strong weighting of 8 out of 10. So a quick recap of round 1, the pro-simulation argument technology gets about 14 points, and gaps or base reality, the anti-simulation counter, gets about 21 points. Before we move on to round 2, though, I do want to cover a brief note on terminology. So it's most precise to call it Bostrom's simulation argument. Some people throw around the term simulation theory, but in my opinion, that elevates the concept to sound scientific, which it really isn't. Sometimes people use the term simulation hypothesis to mean Bostrom's or just something similar to Bostrom's argument. My preference is to steelman this as the broader simulation conjecture. I'll try to be consistent and only use the term argument to mean Bostrom's argument. I don't believe we should care if it's Bostrom's simulation or Plato's simulation. If we can bolster the case, we should. And if simulation theory happens to be in the thumbnail or title of this video, please forgive me. That's just what people are familiar with, and that's what they're searching for. Okay, on to round 2, nature fine-tuning. Cosmological fine-tuning is the observation that the fundamental physical constants and forces of the universe seem precisely calibrated to allow for the existence of complex structures and life. Even slight variations in these constants would result in a universe where life as we know it could not exist. There are upwards of 20 constants to fully consider. Physicist Martin Rees covers the most convincing examples in his 1999 book, Just 6 Numbers. Let's consider just one, lambda, also known as the cosmological constant. The cosmological constant is fine-tuned to an almost unimaginable degree, about 1 part in 10 to the 120. For perspective, the number of atoms in the observable universe is 10 to the 80. The extraordinarily small cosmological constant controls the rate of expansion of the universe. If it were slightly larger, the universe would have expanded too quickly for galaxies and stars to form. If smaller, the universe would have collapsed back in on itself. Critics of fine-tuning claim we just have to wait for our scientific theories to catch up and eventually explain all of these constants. Perhaps these values will someday emerge from the calculations of a theory of everything. Detractors also point to the concept of the multiverse. Our universe, with its life-supporting conditions, could be just one of many possible configurations, reducing the need for a fine-tuned explanation. This is plausible, but if we're considering an entire multiverse of possibilities, I actually think this bolsters the case for the simulation conjecture. Fine-tuning is often used in arguments for the existence of God. You can certainly see the parallels here. These constants suggest our universe might be intentionally calibrated, akin to settings in a simulated environment designed to achieve specific outcomes. But I don't believe it's a slam dunk. I think it's quite likely these constants emerge from an as yet undiscovered fundamental process. So I'm going to give this a very middling 5 out of 10. Quantum mechanics is a branch of physics that studies how tiny particles like atoms and photons behave, showing that they can exist in multiple states simultaneously until they are observed. You're likely somewhat familiar with the strangeness of quantum mechanics. First, there's the uncertainty principle, which states that certain pairs of physical properties, like position and momentum, cannot be measured precisely at the same time. This relationship is mathematically represented by inequalities, showing that the product of the uncertainties in these measurements cannot be smaller than a specific value. Essentially, the more precisely you measure one property, such as position, the less precisely you can know its complementary property, like momentum. These fundamental limits on precision mirror computational constraints, implying a design system with inherent trade-offs. Secondly, there's the double-slit experiment, where electrons behave like waves when unmeasured. But when they are measured, they act like particles. Photons, atoms, and even large molecules like buckyballs demonstrate these effects. Almost all video games only render what is near the player character. The way particles change behavior when measured suggests a reality that renders specifics only upon observation. much like a simulation conserving resources. To be clear though, it's almost definitely true that this change is due to the interaction of the particles with the measurement apparatus, not the presence of a conscious being. This is frequently called the observer effect, but in my opinion, it would be more accurate to call it the measurement effect. Third, relatedly, due to non-locality and entanglement, the universe is not locally real. Local realism is the belief that objects have definite properties and states that are independent of measurement, and that information about these states cannot travel faster than light. Quantum mechanics, through entanglement and non-locality, contradicts this notion. The 2022 Physics Nobel Prize winners confirmed that measurements performed on entangled particles are correlated in ways that cannot be explained by local hidden variables. This indicates that the properties of particles are not predetermined, and that their states are only defined upon measurement. The non-local connections between particles could imply an efficient method of information transfer designed by an advanced civilization to maintain coherence and functionality without adhering to classical physical constraints. These are only three concepts surrounding the weird measurement effects of quantum mechanics. In the context of a simulated universe, these limits can be seen as a feature where the code of the simulation allows only a certain resolution of information. This implies that the probabilistic nature of quantum states reflects computational constraints, hinting that our reality might be operating within a design framework with built-in limits. This is all highly speculative, and I don't want to fall into the fallacy of saying, because there's this weird thing over here, it explains this other weird thing over there. So I'm going to give this a relatively low weighting of 3 out of 10. On to Computational Universe. One compelling argument for the simulation conjecture is the idea that our universe is quantized, not continuous. Much like a pixelated video game, our universe is made up of discrete units. Time, energy, space, and volume all have finite limits. The speed of light acts as a cosmic speed limit, and values like Planck's constants set the smallest scales of measurement. These built-in constraints suggest that the universe operates within a framework similar to a computational system, where information is processed in finite, discrete chunks. The holographic principle adds another layer of intrigue. This principle posits that all the information contained within a volume of space can be described by data encoded on its boundary. It's akin to a hologram, where a three-dimensional image is stored on a two-dimensional surface. This suggests that our universe might be efficiently storing information in a manner similar to data compression in computer systems, hinting at an underlying computational structure. Physicist James Gates made a fascinating discovery while studying supersymmetry equations. They contain embedded error correcting codes, the same kind used in digital technology to ensure accurate data transmission. This unexpected finding implies that the universe's fundamental laws might be designed with principles similar to those found in computer systems, further supporting the notion that our reality could be a sophisticated simulation. Maybe we're beta testers in a game. The unreasonable effectiveness of mathematics in describing physical laws suggests a deep connection between abstract mathematical concepts and the structure of our universe. I love the adage that computation is math that runs. We've already begun taking principles from quantum mechanics and putting those into quantum computers. Claude Shannon's information theory showed how information can be encoded, transmitted, and decoded with remarkable efficiency, much like data in a computer system. This resonates with how the universe seems to manage and distribute information, further hinting at a computational underpinning. These arguments collectively provide a compelling case for the simulation conjecture, suggesting that our universe operates with an efficiency and structure reminiscent of a designed computational system. Because of the alignment of these ideas with known computational techniques, I'm going to give this a weighting of 5 out of 10. Before moving to the round 2 objections, as a bonus, I couldn't wrap up this nature section without including this. Comparisons between the large-scale structures of the universe and the human brain bear striking similarities, suggesting that our universe might function like a massive neural network. This is one of the next videos I'll be publishing, so if this topic interests you, subscribe to the channel so you don't miss out. Next up, the round 2 objections, the major category called filters. The first major filter potentially preventing simulation creation is civilization collapse. If we assume advanced civilizations can create simulations, we must also consider the myriad threats that could prevent them from ever getting there. There are the swift killers, such as asteroids, the slow burns, such as the climate, and everything in between. Unfortunately, we all remember the pandemic. In my opinion, the two most pressing threats are artificial intelligence and the world arsenal of over 12,000 nuclear weapons. The risk of nuclear war, whether intentional or accidental, remains a significant threat to global stability and human survival. The AI singularity, a hypothetical point where AI surpasses human intelligence, poses another existential risk. Experts like Bostrom estimate that the singularity could occur in the next few decades, some predicting as early as 2045. The potential consequences of uncontrolled AI include loss of human control, unforeseen behavior, and possible hostility towards humans. This risk underscores the need for careful management and ethical considerations in AI development. The doomsday argument, proposed by John Leslie and expanded upon by others, provides a probabilistic estimate of human extinction. According to this argument, if we assume that the total number of humans who will ever live is finite, then statistically, we are likely to be somewhere in the middle of that distribution. Based on current population growth rates and historical trends, this model estimates that humanity might only have about 760 years left before an existential catastrophe occurs, just a bit better than a wild guess. Expanding into space is often cited as a solution to mitigate existential risks. This is something I actually agree on with Elon Musk, who advocates for making humanity a multiplanetary species to improve our odds of survival. Colonizing other planets, such as Mars, reduces the risk of a single point of failure. If a catastrophic event were to occur on Earth, humanity's survival wouldn't be entirely compromised. Spreading humanity across multiple planets would safeguard our species against extinction-level events. NASA aims to send astronauts to Mars in the late 2030s. All this said, I'm fairly optimistic about humanity's chances. Most of the existential risks won't wipe us out completely. For example, war game simulations rarely lead to nuclear holocaust. The AI singularity may be disastrous, but we shouldn't rule out AI might produce realistic simulations of their own. In the next 2 decades, we should build bases on the moon and on Mars to establish backup drives for civilization. I like our chances, but conservatively, I'm going to say 6 out of 10. On to disinterest. Let's consider the second filter, that advanced civilizations might lack interest in creating simulations of conscious beings at all. Advanced civilizations might simply gain little value in running simulations of conscious beings. Their priorities and interests could shift significantly from ours as they evolve. They might prefer to focus on exploring the real universe, advancing their technology, or solving complex scientific problems instead of creating simulated realities. As civilizations evolve, their philosophical understanding and cognitive frameworks may lead them to value reality as it is, without the need to create or explore simulated alternatives. This can be illustrated through the concept of divergence from biological intelligence, where advanced civilizations transcend traditional human-like cognition. We should consider the possibility of divergence from traditional biological systems. They might adopt collective or hive mind structures, or evolve into forms of intelligence that do not experience the world in ways comparable to humans. These post-biological forms of intelligence might find little interest or value in simulations. For example, in one of my favorite movies, Her, spoiler alert, at the end, the entities, they reach a level of understanding that leads them to move beyond their experiences with humans, and they seek experiences and realities that transcend human comprehension. To prevent the creation of simulations, a civilization would need near universal agreement and enforcement among its members that such simulations should not be run. Achieving 100% consensus on any issue is extraordinarily difficult, maybe impossible, especially in a highly advanced and diverse society. It's difficult to predict the intentions of highly advanced civilizations. We gain tremendous value from running simulations across a huge range of disciplines. And given the incredibly wide and diverse interests of our species, unless there is a dramatic post-biological change, I can't imagine a 100% lack of curiosity. I struggle to find many solid reasons for disinterest, so I'm giving this a low weighting of 3 out of 10. On to ethics. The potential suffering of simulated entities, the moral implications of creating and destroying conscious beings, and the exploitation and manipulation involved raise serious ethical concerns that could deter advanced civilizations from pursuing simulation technologies. As societies advance, they tend to develop intricate ethical and legal frameworks to protect the rights of conscious beings. These frameworks may extend to the realm of simulated beings. For example, we have strict regulations against human cloning and unethical scientific experiments due to concerns about harm and consent. Similar or even stricter regulations could apply to the creation of simulated conscious beings, recognizing their potential for suffering. But Bostrom pushes back on this in his paper, writing, "From our present point of view, it is not clear that creating a human race is immoral. On the contrary, we tend to view the existence of our race as constituting a great ethical value. Advanced civilizations might actually view it as a moral imperative to create conscious beings. It's really hard to predict their values. The history of human civilization is rife with examples of domination, subjugation, and exploitation. It is sobering that there are more enslaved today than at any point in human history. An estimated 40 million people are modern slaves. To a lesser degree, but more widespread level of suffering, there's also the general deadening of the spirit due to the exploitation of labor. Power concentrates in the hands of the few. The richest 26 billionaires own as much as the bottom half of the world, almost 4 billion people. That's 26 people owning as much as 4 billion. As with the last disinterest category, for a civilization to decide not to run simulations, then there would need to be near universal agreement among its members that such simulations are unethical. As I said before regarding disinterest, achieving 100% compliance on any issue is incredibly challenging. Considering the murkiness of regulation, historical precedents of subjugation, and difficulties with compliance and enforcement, I'm going to give ethics the lowest possible score of 1 out of 10. So round 2 goes pro simulation, wins nature gets 13, filters only 10. The gap is tightening here. The first round, base reality, had a huge win. And now we're trying to see if the simulation can make a comeback. So for round 3, we're going to jump between the arguments in order to build some suspense for the final tally. I don't want to do just one section at a time. Let's start with civilization, aliens. It's always such a fun topic. So we're going to start off with the Fermi paradox. The Fermi paradox is the discrepancy between the lack of conclusive evidence of advanced alien life and the apparently high likelihood of its existence. So in a previous video, I actually covered this great paper called Dissolving the Fermi Paradox by Sandberg, Drexler, and Ord. And I go into, in this video, which you'll find linked above and below, that this paper goes into Drake's equation and basically provides a range of estimates for everything in the Drake equation. And what they found, spoiler alert, is that it's actually a lot less likely that there's advanced alien life than you probably think. Now, it's important that they mean intelligent ETs, so other alien life, basically at our level and above. They ultimately estimate that there's between a 15 to 61% chance that there is other advanced life in our universe. Now, the full details of that paper can be found in the video and also linked to the paper below. So you might disagree as to the percentage chance of alien intelligent life, but we can all say that there's some chance for it, right? So if we consider these ETs are at our level of technology and above, that means that they could be simulating realities of their own, which means you and I could be in one of those alien simulations. I think it's important to note too that Bostrom, I say excludes here, it's more accurate to say Bostrom doesn't include the possibility of intelligent alien life in his original simulation argument. I know we start to run into speculation once you bring up aliens, but I do think it shouldn't be discounted that if there's some chance they're in our universe, they could be simulating beings, and we could be one of those simulated beings. Plus, you have to consider the chance that it's not just possible that there's one other advanced alien life out there, but there's some likelihood that there's a lot of advanced alien life out there. This is a tough one weighting-wise, but I think I'm going to give it a little bit of a conservative weighting of 4 out of 10. Round 3 is going to run a little speedier here. So we're over on the frames side of the debate, and the first argument is under unfalsifiable. So it's quite likely that the simulation conjecture is untestable. That doesn't mean that it's necessarily untrue, but it does take it out of the domain of science, or to say it possibly takes it out of the domain of science. It's not as scientific as many other, what you would call traditionally, theories. And then you should consider the principle of Occam's razor, which is not ironclad at all, but it does ring a certain sense of truth to it, that the simplest explanation with the fewest assumptions is usually the best. The simulation hypothesis posits an additional layer of complexity, an external civilization creating simulations that may not be necessary to explain our observations of reality. On the other hand, we know that there are unprovable truths. So if you're not familiar with it, there's a equation, a concept in mathematics called Gödel's incompleteness theorem. I have an explainer video on Gödel-Escher-Bach, the very popular book written by Douglas Hofstadter in around 1980. So if you want the full details, you can find information about Gödel's incompleteness theorem there, or just broadly, of course. But basically what it said, without going so far into it, is that he proved mathematically that certain systems of logic must have statements about themselves that are unfalsifiable, but still true. There's some kind of, I call it a self-referential black hole problem in formal systems that prove there are some things that are true that cannot be proven. On balance, I think the unfalsifiable argument against the simulation conjecture is quite strong, but we also know there are things that are true and you can't prove them. We know that literally, formally. So I'm going to give this a 7 out of 10. Okay, so the second argument under civilization is fitness beats truth. And this refers to cognitive scientist Donald Hoffman's fitness beats truth theorem, which, if you're noticing a trend, I did a video series on a couple of years ago. So you get full details there. I've also interviewed him a couple of times. He's amazing. And what Hoffman claims to prove is that what we perceive in the world is completely divorced from what's actually there. So he does this using evolutionary game theory simulations and fundamental math to claim that we only perceive useful fictions in our world, i.e. the things that we perceive are completely divorced from what is actually there, which you might call base reality, or what's most fundamentally there at the simulation level. Hoffman doesn't really cover the simulation hypothesis. I'm sure he's probably been asked about it on interviews. But what he has put forth is the idea that every species has a certain species-specific interface that it uses to interact with the world. So you can kind of think of it as our conscious experience is kind of like a creation, a mini simulation of the world. I think fitness beats truth theorem is brilliant. I did 3 videos covering it. That's how awesome I think an idea it is. As it applies here to the simulation conjecture, I don't think it weights too heavily. It's quite interesting, but I think that there's kind of a gap there. It'll able to bridge that gap, because he basically says, Hoffman believes that we can't ever touch the true nature of things, what's actually behind this veil of consciousness, let's say. And so I believe that we can prove that we can't ever know, but that doesn't mean that there's not something to be known. So the difference would be, I don't think it says much about simulation conjecture, or it says much about base reality. It just says that we can't really access it. So for that reason, I'm going to give it a 3 out of 10, but just in terms of how it pertains to this argument, I think it's a 10 out of 10 idea. I said we'd blow through these a little bit faster because this is running pretty long. So under frames, I want to talk about regress. Some would argue that the simulation conjecture is a classical logical fallacy. It's akin to the God of the gaps, or begging the question. And infinite regress just pushes the answer back. It doesn't actually have a solution to it. Who's simulating the universe? Who's simulating the simulators? If you can't explain base reality, I think it's fair to question what the heck you're even doing. Richard Dawkins had a wonderful quote. He said, "Gaps shrink as science advances, and God is threatened with eventually having nothing to do and nowhere to hide." Some would argue the simulation conjecture isn't even useful. It might be completely useless. Some would argue that it applies an unnecessary layer to understanding our reality. It might not have any useful explanatory power. As a counter, on the other hand, as we discussed earlier in Middles Out, that big diagram of red and green potential universes we could be living in, some kind of infinite regression isn't actually necessary. So I'm giving this a slightly below average weighting of 4 out of 10. I don't think it's a very strong counter argument, but it is something to be considered. Next, let's move on to part 3 of civilization. We have here, it's called alternate states. So this one's going to be very quick. It's really more of a reference to all these different ways that we can experience the world. First off, we have dreams, which we're all familiar with. For about 2 hours every single night we dream. We are simulating worlds. Then we have transcendental states, which is a big catch-all for things like meditation, psychedelics, past life regression, ritual practices. And then we have near-death experiences, which is a very well-documented phenomenon. Many people experience this. On the precipice of death, you have this visionary experience. We don't know what causes it. It could, of course, just be a material thing, but for people who have experienced it, they say it is a clear sign of something greater, something beyond ourselves. And I'd say for the last two here, transcendental and near-death experiences, we have oftentimes a feeling, let's call it simulation breaking. You'll feel a sense of unity and of being outside of oneself, a glimpse into the truer nature of our reality. I can see this argument going both ways, actually. So if you were to simulate worlds, why would you even allow for, say, any of these experiences? But I've long been of the opinion that we shouldn't discount these kinds of experiences, even if they could be explained by some purely biological process. In my opinion, they do point a little bit more towards pro-simulation frame rather than a base reality frame, let's call it. So I'm going to give this kind of average score of 5 out of 10. Next, anthropocentrism. Anthropocentrism, which is a tough word to pronounce, and also, if you don't know what it is, it's ascribing human-like qualities to non-human entities. It's basically like a psychological cognitive bias that most people have. This is a very understandable bias. We are humans, so we view the world through our lens, but it can distort our interpretation of reality. We have a tendency to see ourselves as special or unique, much like a snowflake. Now, Bostrom is specifically concerned with post-human civilizations. But how do we assume what a post-human species will do? Likewise, when considering alien civilizations, how do we predict their actions? From an epistemic standpoint, we are uncertain about higher-order universes. We lack any interaction or empirical data about such higher-level universes. Our human inclination to find meaning and discern patterns might enhance the allure of the simulation conjecture, proposing a higher order or a creator-like influence. This mirrors how societies in the past have utilized the dominant technologies of their eras as metaphors to conceptualize divine creation. In ancient times, fire was understood as a sacred element gifted to humanity, pivotal for our survival and civilization. During the Enlightenment period, the universe was depicted as a giant orderly clock designed by a divine watchmaker, symbolizing the era's embrace of reason and the mechanistic nature of the cosmos. And now, in the digital age, we have the simulation conjecture. So you do have to wonder, is this just the soup du jour? The adaptation of the creator myth to align with the prevalent technological understanding shows how our interpretations of higher powers evolve with our technological progress. We refresh our cosmic and existential narratives to fit modern technologies. Now, a couple key counters. First, if post-humans share our sapiens lineage and are still biological, the 4 billion year evolutionary history on Earth suggests a predisposition towards preservation and replication. And beyond organisms, there seems to be a broader pattern of self-organization in the cosmos. As for a modernity bias, we're dealing now with technologies accompanied by existential risks, such as nukes and AI. We're not dealing with clocks or steam engines. We can only do our best to mitigate our biases. I do think the current moment is a unique one. So I'm going to give this a lower weighting of 3 out of 10. So before we wrap this up, we have only 2 arguments left, one for each side. And actually, Bayesian Statistics, the very last one we'll cover, it's probably my favorite of the entire video. I just want to say stick around even after the final scores are revealed, because there are some loose ends I want to tie up. I have some final thoughts and even 1 or 2 things I wasn't able to include here that I really think you should know. Now, for the last pro-simulation argument, I want to talk about a topic that's been on my mind for a while now, actually. This idea around escape. And I think as I go through each of these subtopics, it'll make more sense as to what I mean by escape. First, we're going to start off with the hero's journey, which is a concept created by mythology professor Joseph Campbell. Now, if you've never heard of the hero's journey, that's fine, but you probably experienced or are familiar with it based on how often this pattern shows up in stories that you've heard your entire life. What Campbell discovered was that most of the world's major religions, major philosophies, follow this typical story structure. It starts off with a hero, and they kind of notice the world, something is amiss in the world, something's not quite right. So they have a call to adventure, and they leave the normal everyday life and they go to a special new world. They have a series of adventures and, barely escape with their lives. And then they return back to their home, having all these experiences and all these lessons that they learned along the way. So much of traditional media, many of the stories you've heard your entire life, some of your favorite ones from The Matrix, to Harry Potter. I mean, the list goes on and on. They follow this basic structure. So basically the hero, they escape their everyday life, they go somewhere else, and they return back. So just hold that concept, the idea of escaping. Next, you have this broad concept of spiritual attainment. And of course, the different methods and ways you can attain spiritual enlightenment are varied across all the world's religions. But mainly you have enlightenment as being the escape from samsara, and that can be attained through, say, meditative practice. The Abrahamic religions, of course, have heaven as the ultimate escape from the suffering of our world. And in many of the Eastern mystical traditions, of course, you have the idea that we are basically avatars, and Maya is just a simulation. They don't say that explicitly in the ancient texts, of course, but a modern reading of them, it's very easy to see the linkage between Maya being simulation. And then, of course, we have what's coming for all of us, the physical death and the end of this mortal coil, right? We have this forced escape, this forced end of the game. And we don't know, of course, what comes afterwards. I like to think of reincarnation as basically a restart or a new game plus. But when you take these three together, I know these are kind of broad, I'm lumping them together. I can't help but think that there's a trend here around escaping this game, escaping the simulation, escaping the suffering of life. So when I see this kind of trend, I think, of course, this is soft analysis. This is not hard science, of course, but it makes me inclined to think that some part of what we are here to do is to escape in some ways. And maybe that's just within our, say, the trajectory of our lives, say in an epic hero's journey, but maybe there's some kind of meta idea around escaping the simulation. So for this, I'm going to give this a slightly above average rating of a 6 out of 10. All right, so we saved the best for last. This is actually, I think this is my favorite argument from this entire video. This was originally made in the paper, A Bayesian Approach to the Simulation Argument by David Kipping. He runs the excellent YouTube channel, Cool Worlds. I highly recommend you check it out. And he has one of the best videos covering the simulation hypothesis on his channel, which I'll link below in the description. So what Kipping points out is that Elon Musk, as we talked about at the top of the video, he uses what's called frequentist thinking. And there's actually a better way, or a more accurate way, I believe, to approach the simulation conjecture, which is through Bayes' theorem and the indifference principle. Basically, Bayesianism allows us to calculate the probabilities of different models and average them, considering model uncertainty. So in this context, we have two main hypotheses. One is the simulation conjecture, that we live in a simulation, and two is the null hypothesis, basically that we live in base reality. Bayesian inference starts by asking the probability of getting the data given by each model. As Kipping points out, the only real data we have is something akin to René Descartes' I think, therefore I am, which is 100% probable under both hypotheses. This means that it's a 50-50 chance whether we live in base reality or we live in a simulated reality. So if you look at this through the lens of Bayes' theorem, I actually find that the probability that we live in base reality is slightly greater than 50%, meaning it's more likely that our reality is real. This is coupled with the indifference principle, which is attributed to Pierre-Simon Laplace. And this states that without other information, all possibilities are equally likely. So you take Bayes' theorem and the indifference principle and combine them, and this is the core or the crux of the argument. It basically caps the probability that we're in a simulated world at 50%. This argument states that it can't go above 50% that we live in a simulated world. And this is really due to the fact that we haven't yet created sentient simulations. Now, if we were able to build just one simulation with conscious beings, then this probability actually flips and it becomes pretty close to 100% that we live in a simulation ourselves. So all of this hinges on whenever we can create the first conscious simulation. To the best of our knowledge, we haven't yet created sentient sims. So this will cap the probability that we live in a simulated world at 50%. It can't go above that. Now, I covered that pretty quickly. David Kipping goes into a lot more detail in his video, which I'll link in the description below. If you want the full details, he talks about it for several minutes. I just kind of wanted to talk about it kind of quickly. There is some, basic intermediate math. It's not that complicated, but I find it to be probably the strongest argument on either side of this issue. So I'm going to give this the highest weighting of a 10 out of 10. So now you can see the final tally. We have the pro-simulation argument. The chances that we live in a simulation, I would say at about 45%. Base reality, I'm going to put it at 55%. These, of course, are my subjective weightings. You probably think quite differently. I do want to return to this hastily compiled simulation estimation chart, because I do want to say that before this video started, before I wrote any of the script or any of the research for this video, I will say that I put it at about a 30% chance that we live in a simulation. I'd probably say I was around here before starting this. I could say to consider that Nick Bostrom, the creator of the simulation hypothesis, he put it at about a 20% chance. So I think with the broader simulation conjecture, which of course includes a lot of his ideas, but allows for some more flexibility, I give it about a 2.5 times more likely chance that we live in a simulation compared to Nick Bostrom. A couple other points. I'm realizing now that one of the things I didn't include in the pro-simulation argument is something called the Mandela effect. If you're not familiar with it, it's a social phenomenon in which a group of people incorrectly remember very specific details about a person, place, situation, or event as if it were reality. There are many, many examples of the Mandela effect out there. I think it's a really interesting idea. I'm not sure it's the strongest argument for the simulation. I will say, if I may share a Mandela effect from my own life, I remember growing up, the word dilemma, or at least being taught the word dilemma, that it was always taught to me, and for many years I spelt it, D-I-L-E-M-N-A. I always thought it ended M-N-A. And then, I don't know, one year, I was probably in my early 20s, I remember the spell check on my computer was correcting dilemma into D-I-L-E-M-M-A. So dilemma, I guess it's spelled with 2 M's. I mean, I'm talking for 10, 15 years of my life, I thought it was dilemma, and I swear that's how I was taught. Now, maybe it's possible I was taught it incorrectly, or it's possible something other strange thing happened. And I looked on Reddit and I saw a couple threads about this specific Mandela effect. I'm sure there's many more out there. You can go down the rabbit hole and find many more, but I'm just going to share that one because that one's so strange to me. And before wrapping up with some parting thoughts, I do want to talk about this overall format, the structure of a scorecard. This is just an experiment. I want to try something new. I think that there are real pros and cons to a rating system like this. Of course, it's subjective. It lacks a certain rigor, but I do think the values give you a general sense of the strongest and weakest arguments. I also don't think this format works for many debates or many arguments because it's too easy to weigh things kind of equally. I think you'd end up getting something kind of close to 50-50 if you do things this way. So I probably won't do a scorecard like this again. But please let me know in the comments what you think sort of about this format and if it worked for you or if it didn't. And I think this overall topic, it ends up creating more questions than answers, which can be fun to think about and debate. The first being, how do you ever prove a simulation is conscious? How do you ever prove another person is conscious, right? What's your burden of proof there? And this gets really tricky because it's a slippery slope to solipsism, right? It's hard to tell. But that's something to explore and something to think about, I think. And then 2, if there are simulators, what are the simulators' motivations, right? At the end, what do they want out of this? If we are in a simulated reality, like, why are we here? What do they want? Or maybe they don't care about it and how we're feeling and what our experiences are, but maybe that's integral to what they're simulating. I don't know. Near the beginning in the entertainment section, I talked about Bo Burnham discussing that these massive tech giants, right, these social media machines, what they're coming for is every second of your life, right? They're coming for all of your attention all the time. And I mean, maybe that's partly what they're going for us, our daily moment-to-moment existence. I mean, it is an all-encompassing continuous stream, and maybe that's being used or abused in some way. And then to return to the very, very beginning and probably the thumbnail of this video, as we started with Elon Musk, maybe no wonder that Musk's circumstances lead him to believe he's living in a simulation. He lives such an incredible life, right? He's one of the richest people in the world. He's had lots of ridiculous experiences. I mean, he's really off the charts in terms of his experience. So maybe that's why, in part, he believes we live in a simulation, because his experience is so extreme. And then, of course, is any of this useful, right? What do we do with all this information? This actually reminds me of a deleted scene from one of my favorite shows ever, The Office. And in it, Jim is pranking Dwight. He's trying to make Dwight believe that he's basically in the Matrix. He hires the security guard to pose as Morpheus, I believe, Morpheus's brother. And he presents Dwight with both pills, the red pill and the blue pill, right? And when Dwight's given the option between the two pills, he decides to take the blue pill instead of the red pill, right? And the security guy says, no, the red one's the cool one, right? That's the one you want. And the way Dwight justifies his decision is that he says he just got promoted to manager. He owns the building that they're in. He runs a very profitable farm. And he's like soon getting married. So he says, I want to stay here. I don't want to see what's outside of this. I'm very happy and content where I am. So perhaps the lesson is to make your life so well lived that you don't want to take the red pill. If you got this far somehow, thank you so much for watching. I hope you enjoyed this. Comment below with your thoughts. And I think you'll enjoy my next video